Here is something that I find to be so strange, yet so cool at the same time. Y equals b to the power of ln x is the exact same function as y equals x to the power of ln b. Assuming that the domain of these functions is x greater than 0, and b should also be some positive real number. And normally we don't want b equal to 1, because then we would just have a constant function. But in this case, we could let b equal to 1. The two forms of the function will still be equivalent when b is equal to 1. But in any case, under those conditions, those are the exact same functions. And the proof is actually pretty straightforward. It just relies on the properties of logarithms. So let's say we start with the function y equals b to the power of ln x. Let's take the natural logarithm of both sides. So then we would get ln y equaling ln of the quantity b to the power of ln x. And now using the power property of logarithms, we can bring that power of ln x down in front of the ln b. So now we have ln y equals ln x times ln b. And now we just do a little switcheroo. Now we just bring ln b up as a power of x. So now we have ln y equaling ln of the quantity x to the power of ln b. And then we just cancel out the ln's on both sides by raising both sides as powers of e. And that will give us y equals x to the power of ln b. And so now we have y equaling both b to the power of ln x and also x to the power of ln b. So that implies that these indeed are the same functions, at least under those conditions I stated earlier for b and x. But in any case, I first learned about this fact from a comment that was left by one of my viewers on a previous video. So thank you, MathNerd1729, for showing me this. I honestly was not aware of this fact, or I had never made this connection in my head prior to reading your comment. All right, with that, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch y'all in the next one. Take care.